Hello. For my final physics project, I will be exploring the physics behind a washing machine. And you may be wondering, why a washing machine? Well, there's no crazy backstory or anything, and I've never been stuck in one before, but I chose it just because when I was thinking about the project, I was cleaning up my room and had to do a load of laundry. And when I put it in, I saw the clothes start to turn and stuff, and I was like, that's some rotations right there, and there's probably some physics behind it. Washing machines are relevant in my life because they are a machine that will clean your clothes, bed sheets, and all that need to be clean. And I try to use it once or twice a week just to stay on top of it, stay clean. So I know that you all are wondering what a washing machine looks like, and let me walk you through the design. In the video, there will be multiple displays of different designs of these washers and how they may look. The outside of a washing machine is this bulky cubicle shell that makes it almost impossible to move. Inside the shell, there will be a door and either on the top or on one of the sides. This is a place where you'll oftentimes place the clothes, and as you can see in the pictures, the inside of the machine is circular. There will also be buttons on the sides and a place to add soap so you can customize the wash to make it how you would like. As mentioned earlier, all I know about the physics behind a washing machine is how it spins on the inside.
So I decided to do some in-depth research, and I found that washer machines tend to use centripetal forces and also friction to clean clothes.
Also, thinking of a way to power the machine, it definitely needs some electricity to power the machine, and a big part of this electricity will go into heating water along with running the machine. When a washing machine is running, there are two major cycles. The first one is a wash cycle where the clothes inside of the machine will get soaked with soap and water. Then there is also a rinse and spin cycle where this cycle cleans the clothes and removes any excess water. In the wash cycle, there is water released inside the machine, and there's also a motor that makes the agitator spin. The agitator is a part of the machine that is located in the center, and when rotated, it also rotates the clothes. This movement of the agitator creates friction between the clothes and it itself. This friction will then make all the dust and dirt in the clothes separate and allow the water and soap to clean all the parts of the clothes itself. In the rinse and spin cycle, the clothes are then spun by the motor itself. You may be thinking to yourself, how is spinning the clothes going to dry them? Well, it's due to the washer and its design. So the circular inside of the washing machine, as mentioned before, has two drums. It's made of two drums. The outside drum is a solid material that is able to hold water, while the inside one has many holes in it. When spinning, there's a centrifugal and centripetal force acting on the clothes and water. And so due to this, the small holes on the inside of the drum, the centrifugal force makes the water drain out into the outside of the drum, while the clothes stay inside due to the centripetal force balancing out. The average washing machine takes about 2,000 to 2,500 watts of power to run a load of laundry on hot water. But if you want to save power and use cold water, it'll only need about 500 watts. So the big takeaway here is just use cold water unless needed. Now let's take a closer look at the diagram of a washing machine. There is the agitator in the center with the inner and outer tubs, or as I call them, drums, as I mentioned before. There are also valves and pumps connected to the inside of the washer to make water to allow water to be removed and added during the wash. It isn't labeled, but in the bottom there's a motor that is making the whole system work. I also read that oftentimes the bottom of these washers are made out of cement so the washer doesn't tip when it's spinning on its fastest cycle. Now, the diagram for a side door washers are very similar to the upright ones, except one major difference. There is no agitator in the system. However, there are drum paddles which do the same thing in theory as an agitator by it creates friction with the clothes. Washing machines and some salad tossers are very similar to one another. Salad tossers have two shells like a washing machine, with the inside shell being something water can pass through, while the outside one catches the water. In this example, my hand is pressing down on the center of the salad tosser, which acts as a motor, causing the inside drum to spin. To recreate a washing machine in a lab experiment, all you would need is dirty clothes, a motor, two shells with one of them being something water can pass through, something that can be placed in the inner shell to create friction with the clothes, and water and soap. There are many calculations that can be made to optimize different aspects of the washer. For instance, you could calculate the power used in the machine, the amount of water and soap necessary to clean the clothes, how fast the washer is spinning, and the best agitator to create friction with the clothes. If the experiment you were trying to measure was how clean the clothes were after a given varying power, the procedure would look something like you would place a piece of dirty clothing inside the inner tub with the agitator. Then simply add some water and soap and spin the inner shell using the motor. After the clothes have been washed, see how clean the clothes were and compare it to the power that was used. Then repeat this experiment with different power supplies while keeping everything else constant. This will optimize the amount of power used for the best result of clean clothes.